Hi friends, today we discuss about cryopreservation. Cryopreservation means it's a long-term storage method. So by cryopreservation we store an intact living cell, tissues or organs under ultra low temperature. So the ultra low temperature is mainly provided by three methods. First of all, one is by in deep freezer. Under the deep freezer the temperature is minus 80 degrees Celsius, and by in vapor phase nitrogen the temperature is minus 150 degrees Celsius, and by liquid nitrogen the temperature is minus 196 degrees Celsius. So cryopreservation is the preservation of intact living cell at ultra low temperature. Okay. Stored materials in cryopreservation is enter into a absolute quiescence stage. The absolute quiescence stage means the biological and biochemical activity are completely inhibited. So this about the cryopreservation. So cryopreservation is the preservation, or it's a long-term storage of living cells, tissues or organs under ultra low temperature. Okay, so next the main advantages of cryopreservations. The first advantage is it is the storage or preservation of biological activity of a cells or material, and the second one is there is no chance of contamination of bacteria or fungi, and the third one is there is no required any more space or labors. So these are the main advantages of cryopreservations. Okay. Next we discuss about the different steps involved in cryopreservation method. The first step or the most important steps is the selection of material. So we selecting as material, that means the tissues, cell or any required material is selected. So mainly the selected materials are meristems, embryos or seeds or ovule, etc. There are two factors are mainly depend on the selection of material. The first one is nature of material and second one is the density of material. So more dense materials are mainly selected for cryopreservations. The second step is addition of cryoprotectant. So the cryoprotectant are a chemical substance which mainly used to protect the cryopreservation material from cryo destructions. So mainly used cryoprotectants are sucrose, alcohol, glycol, DMSO and some amino acids like prolines. So DMSO means dimethyl sulfoxides. So these are the main cryoprotectants. So generally two cryoprotectants used together, so it's provide more effective or it's give more effective to cryo destructions. Okay. So third method is or third step is freezing. Freezing means cooling or treat to low temperature. There are three methods are mainly used for freezing. They are slow freezing, rapid freezing and dry freezing. The slow freezing means slow frozen of material at slow cooling rate. So the material is dehydrated and survive better. Okay. Then the rapid freezing means it's placed into liquid nitrogen. So it's a rapid frozen method. So the material is immediately placed into the liquid nitrogen. And the third method is dry freezing. So dry freezing means the seed or materials are dried or dehydrated and then it's stored. These are the three methods are used in freezings. So mainly we commonly used method is rapid freezing, or it is the best or prolonged preservation or prolonged freezing method is rapid freezing. Then the third step is storage. The storage is the one of the most important steps because the maintenance of frozen material at specific temperature is a very important. When when the material is freezing or frozen, the material is stored at a specific temperature. So storage is the one of the most important step. So the maintenance of frozen material at specific temperature is very important. So the prolonged storage is mainly at minus 196 degrees Celsius. That means liquid nitrogen. Okay. So fifth step is thawing. Thawing means the frozen material is placed into a warm water bath. So the frozen material is next we place it into warm temperature. Okay, so the frozen material become more activated or it's become biologically activated. Okay, the next step is washing and reculturing. So the thawing substance is next we washed with distilled water and to remove the cryoprotectant and it recultured at a specific medium. So these are the sixth method. Washing the frozen material or thawing material is washed and remove the all cryoprotectant and it's recultured at specific media. Then next step is measurement of viability. So there is a possibility of death occur at the storage stress. That means under the storage condition there are some stress conditions. So under these stress conditions the viability is affected. So there is a possibility of death of the cells. So we want to measure the viability of each cells or the material. So first, so for that we calculating the viability of cells by the method. That means the viability of cell is calculated as number of generated or growing cell is divided by number of thawing cells. Thawing cells into 100. This is used to calculating the viability of cells. So next step is, or the last step is plant regenerations. So the viable seeds are then cultured into variable media and it regenerated into a new organisms. So that's about the different steps involved in cryopreservation. The first step is the selection of material. So the selection of material is mainly depend upon two factors, nature of the material and density of the material. So mainly we selected tissues are meristems, embryos, ovule or seeds, and more dense materials are mainly selected. Okay. Then second steps is addition of cryoprotectants. The commonly used cryoprotectants are sucrose, alcohol, glycol, DMSO, proline, etc. So the cryoprotectants are the chemical substance which protect the materials from cryodestruction. Okay. Then generally two cryoprotectants are used together for more effect. Then third step is freezing. Freezing is mainly involved three methods. They are slow freezing, rapid freezing and dry freezing. Slow freezing is the slow frozen at low cooling rate, and rapid freezing means it's placing the material into a liquid nitrogen. Then the dry freezing means the dehydrated cells or seeds are stored. So mainly we used rapid freezing material or method for prolonged storage. So fourth step is storage. So the maintenance of the frozen material at specific temperature is the very important steps. So for prolonged storage we using minus 196 degrees Celsius. Okay, the fifth method is thawing. After the storage we take the samples and it placed into the warm water bath for recovering. So the material is become biologically active. Then sixth step is washing and reculturing. So the cryoprotectant or the frozen material is washed to remove the cryoprotectant and it cultured in or recultured in a specific medium. Then seventh step is the measurement of viability. So there is a chance of death of cells due to the storage stress. So we want to calculate the viability of the cells. So we using the equations number of generated or growing cells divided by number of thawing cells into 100. Then we got a viability, number of viable cells. So based on that, the last step is plant regeneration. So the viable seeds are selected and these seeds are cultured to regenerate the organisms. So that's about the cryopreservations. The next is the applications of cryopreservations. Cryopreservation method is mainly used to prolonged preservations of biological substance, mainly disease-free propagules and their storage and their propagations. Then endangered species preservations and the preservation or cryopreservations of semens and cryopreservations of immature testicular tissues and cryopreservations of oocytes for in vitro fertilizations and cryopreservations of ovules, etc. are the main applications of cryopreservations. Okay, that's about the cryopreservations.